Hey Nimit, let's go ahead and go through these real quick. So 5a, we have an equation, and notice we do have variables in the denominator. Anytime you have a denominator with variables in it, you want to clear the denominator. So I'm going to do that by multiplying by the least common multiple. In that case, that least common multiple is x squared. So I'm going to do that, and I'm going to multiply every single term. So when I do this first term, right, x squared times 4 over x squared, right? The x squares cancel, so that's just going to be 4 plus, now when I go over here, the x cancels, leaving an x here, so that's going to be 12x, plus, as I come all the way over here, plus 9x squared. Then when we come over here, include the equation, of course, and then we get 0. So now we just have a pretty basic quadratic equation. I'm going to rewrite it like this in descending order. So now we just solve this. Hopefully you know how to factor and solve this, because this is factorable. I do notice that this is a perfect square. I noticed that because of this and this, right? I know that the square root of that is 3x, the square root of that is 2, and this is just 2 times 3x plus 2. If you know that quote-unquote trick, you just know that that's here. But you can factor it just like you would before with a factor diamond and all that sort of stuff. I don't know if you learned the Xbox or not, but if you don't know how to solve this really easily, that is something that we should practice. So anyway, so our solutions are just gonna, are just gonna be, here, let me rewrite that. So it's 3x plus 2, 3x plus 2. And so our solutions, this is a double solution. So we just set one of those equal to 0, and we're going to have x equals -2 over 3. And that's our solution to this. Okay, okay, so this was B. And now this screams to me something, so hopefully they talked about this in your class, something called a U substitution. Okay. Notice I'm squaring this here, and this is of first power, and this last one here is the 0th power. So this is what's called a quadratic form. Just like any quadratic, but we're going to use something called a U substitution, which that means is I'm going to take this thing that you had trouble with in just looking at your work. I'm going to take that and I'm going to make what's called a U substitution. I'm going to say and this is called a dummy variable, U, and I'm going to say this is what it equals. Okay, and now I'm going to take this and substitute it in my equation. So in other words, instead of 4 times this thing squared, it's just going to be 4 times U squared, plus 5 times, again, it's just this thing, U, minus 6 equals 0. So at this point, again, we just have a quadratic equation. So again, you need to know how to do these, and I'm not going to spend a ton of time doing this. So -24, this is going to be 5, so that's going to be 8 and -3. So if you don't know how to use the Xbox, that should be something that we learn how to do. So I have 4u squared and -6. Now I just plug these product sum term into here, so it doesn't matter, order doesn't matter in this case. So I'm just going to have greatest common factor, greatest common factor, greatest common factor, and going this way, greatest common factor is what, a 2. So in factoring this is what I get, 4u minus 3 and u plus 2. So again, however you know how to solve this, you do. But now what's going to happen is when you go through this, you're going to get, you have 2 solutions, right? U is 3 over 4, and u is -2. At this point now, here's where we come back to this substitution. So if I said the solution to this equation is u is 3 over 4, then as I come back, because we want what x is, right? So now I'm going to do this, x minus 5 is equal to 3 over 4. We square both sides, so that's going to be 9 over 16. And so then x is going to be 9 over 16 plus 5. So 5 is 80 over 16. So that's going to be 89 over 16. So, and I want to double check to see if that makes sense in this, and it does. Okay. Now we still have this one here. We have our other solution. However, there's a problem with this one, because if I say u and I put up u here equals -2, I already know that this is not a valid solution. And the reason I know that is because it's negative, and I can't have the square root of something be a negative. So this is called an extraneous solution. So hopefully you guys have learned that. So that's an extraneous solution. Okay. So here's our solution down here. Okay. And then we had, was that number 3, right? Oops, let's get up there. There we go. So write in vertex form. So this is in standard form, a quadratic, and this is our vertex form over here. So hopefully you understand vertex form is this is our scale factor. And then the h and the k are just the location of the x and y coordinate of our vertex. Okay. So we want to write this like this. Now there's a couple different ways you can do it. And again, I don't know how Miss Allen teaches this, but here's how I teach it. We do a lot. We practice this a lot. So I'm just going to replace this with y, and we're going to complete a square. So hopefully you know how to complete a square. Okay. So here's how I recommend doing it. Okay. First things first. Okay. I'm just going to take this 9 and bring it over here. Plus 9. Then I have this. Now we're going to complete a square, but to complete a square, this has to be, the leading coefficient has to be 1. So I'm going to have to divide everything by 2. So what that's going to get me is y over 2 plus 9 over 2. And don't mess with the fractions right now. They're all fine. Okay. And I have this. Well, that's 4x. Okay. So now I have to add something over here to make this a perfect square trinomial. So it's going to be x minus 2. We just cut this in half and square it. And that's going to be 4. -2 squared is 4. But if I add 4 on this side, I have to add it to this side. I'm just going to sneak it in here, right? Because I left that little space open. Here, I'm going to just move that so we have a little more space there. Okay, so once I've done that, once I've added that 4 to each side, I can now take this thing here and just replace it with this. So in other words, just like saying this, right? It's like saying that, and now I have this. Okay, so remember, the point of the whole thing is we want to get it to look like this vertex form up here, so we need to get y alone. So, and again, don't worry about working with the fraction so much as do kind of like in problem 1, we have a 2 in denominator, clear the fraction. Because as we go here, the 2 cancels, I get y, and that's what I want. I want that alone. I come over here, the 2 cancels, I have 4. 2 times 4 is 8, plus, now when you come over here, here's the beautiful thing, that just is the scale factor. 2 times whatever this is. Okay. Now, of course, these add together to be 17. So that's a plus 17 over here. And then we're going to bring that to the other side. So here's what we have. X minus 2 squared minus 17. Oops, like that. And that's what it looks like in vertex form. Okay. So there's a lot of skills in all these that you have to be pretty sharp with, like converting. And this is actually a pretty big deal, being able to convert back and forth easily. So if you don't know how to complete a square, you really need to learn how to do that, because that's going to show up again when you start working with circles in what are called conic sections. So hopefully this is helpful. Let me know if you have any more questions. Okay.